Welcome back to math class with Miss B. I am Miss B, and today's lesson we are going to cover fractions and decimals. Here are your state standards, and what that basically means is by the end of this lesson you will be able to convert between fractions and decimals. Okay, so one of the first things and the main things I really want you to know is that all fractions are ratios, and which means they can be written in this form, A over B. The only criteria that must be met is B cannot be 0. Okay, so where B is a non-zero number. Okay, you can also write a fraction as a decimal by dividing the numerator by the denominator. So the numerator would be the top number, denominator is the bottom number. So in this situation, if I have 5/8 as my fraction, I can convert that to a decimal simply by taking 5 and then dividing it by 8. So if I were to use this symbol, this division symbol, the 8 would be on the outside, the 5 would be underneath. And I'm trying to see how many times can I put 8 into 5. Well, 8 is larger than 5, so that lets me know that it's not going to be any whole numbers. It's going to be a fraction or a decimal. So I'm going to put the decimal right there in front. Okay, so I say, can 8 go into 5? No. Can 8 go into 50? Yes, 8 can go into 50. How many times can 8 go into 50? It can go into 50 6 times. Now I do multiplication. 6 times 8 gives me 48. Now I subtract. I end up with 2. Bring down my 0. And 8 goes into 20 2 times. 8 times 2 gives me 16. 20 minus 16 equals 4. Then I bring down another 0. And 8 goes into 40 5 times. 5 times 8 is 40. 40 minus 40 is 0. So I'm at no remainder. So this is how we ended up with this answer. However, I don't want you to go through this and do it the long way. I'd much rather you punch it into the calculator. I'm just showing you what the calculator is doing and how the calculator got the 0.625. Okay. A decimal that stops means it terminates. It has a definite stop. That's called a terminating decimal. So from the last example, 5/8 gave us the decimal 0.625. It stops right here at the 5, okay? The digit that is farthest to the right is where it stops, okay? There's nothing else after it, so it terminates. It has a definite stop. A decimal that has the same digit or block of digits that keep repeating, that's called a repeating decimal. Okay, because repeating decimals go on forever, we will represent them with this little bar above the repeating digit or the repeating block of digits. So in this situation, if I were to do 2 divided by 3, I'll show you how we get this 6. Okay. So 3 goes into 2 no whole times. So I'm going to put a decimal there. 3 goes into 20 6 whole times. 6 times 3 gives me 18. Now when I subtract, I get 2. I'm going to bring down a 0. 3 goes into 20. 6 times. 6 times 3, 18. Now when I subtract, I get 2. Bring down another 0. 3 goes into 20. 6 times. 6 times 3 is 18. Subtract, and I get 2 again. So as you can see, this pattern will go on forever and will never stop. And since that's the case, it would be pointless to sit here and do this forever, right? So we have to figure out where we're going to stop it. So whenever you have a repeating decimal, which this is, you're going to put the line over the digit that starts to repeat or the block of digits that start to repeat. So the repeating starts at 6. So we're just going to put 1 6 and a line over it. Now, if I were to work out a problem and I got 0.1 2 1 2 1 2 1 2, and I just kept getting those 1 2 1 2 forever, that's what that dot means. Now I will put the line over the 1 and the 2 to let me know that that pattern repeats forever. Both terminating and repeating decimals are rational numbers. Okay, we call them rational numbers because they can be written as a ratio. The word rational and ratio, well, ratio is actually in the word rational. So if a number can be written as a ratio, it is a rational number. Numbers that cannot be written as a ratio are called irrational, meaning not rational. Irrational numbers also cannot be written as a repeating or a terminating decimal. So for example, with the number pi, it's a decimal, it's a long decimal that goes forever. Starts with 3.14159 and so on and so on. And there's no repeating of digits or a pair of digits. So there's no pattern. So it's kind of crazy. It's all over the place. It's an irrational number. So pi is one example of an irrational number. Now I'm going to show you how to write a terminating decimal as a fraction. So I've shown you how to go from a fraction, like 5/8, to the decimal. Sorry, 625. So we went from the fraction to the decimal. So now we're going to go the other way. We're going to go from the decimal to the fraction. To do that, you're going to need to use decimal place values. Okay? The decimal place values are actually powers of 10. That's how we got the decimal place names. Okay? So when we say powers of 10, we mean 10 to the first power, 10 to the second power, 10 to the third power, 10 to the fourth power, and so on. Okay? 10 to the first power, that is just 10, right? So the very first decimal space, if this is my decimal space, right, my decimal point right here, the very first space to the right, that is the 10th place. It's the first power of 10. The next space, that would be 10 times 10, because that's how we get 10 to the second power, right? Which is 100. That is why it's called the hundredths place. The next place would be the thousandths place, because 10 times 10 times 10 equals 1,000. And then the next place will be the 10,000ths place. Okay, so those are our other two decimal spaces. They continue to the right. So this would be 10 to the 5th power, 10 to the 6th power, and so on and so on. So to go from a decimal to a fraction, what you're going to do is you're going to place the digits of the number. So here's my decimal. My digits are 2 and 5. That's what I'm going to place in the numerator of my fraction. And the denominator will be the power of 10 that the last digit falls into. So my 5 was in the hundredths place. So that lets me know that this is 25 hundredths. So I will have 100 in my denominator. Now I just need to reduce. What can I divide both 25 and 100 by? I can divide both of them by 25, right? And it reduces down to 1/4. So if I have 0.25, the fraction equivalent to that is 1/4. It's going to be the same process when you have a number like 1.8. So this is, we have one whole and then a part of another whole. That's what the decimal part is all about, right? So I know that this is going to be a mixed number. It's going to be one whole, and then I'm going to have a fraction attached to it. So I have the one whole, 1. In the fraction part, I have 8. That's what I'm going to put in my numerator. Remember, you put the digits for the decimal in the numerator. And my 8 is in the 10th place. So that means it's 8/10. And then I can reduce this down to 1 and 4/5.